All right, let's look at another one. Let's take this rational function, pick out its important characteristics, and graph it. The first thing I'd like you to do is I'd like you to factor the numerator and the denominator so you can see all the pieces it's made of. Hopefully you noticed in the numerator that there's a GCF, a greatest common factor. Before factoring, I always factor out a greatest common factor first if there is one. Now you should be able to factor it even farther using our basic factoring techniques. I also would like you to factor the denominator. Once it's completely factored, you should have factors shown here, a 3 times an x plus 2 times an x minus 1 on the top, an x minus 4 and an x plus 3 in my denominator. Are there any factors that reduce, or is this in most simplified form? It looks like, again, on this one, it is in most simplified form, so it looks like this function has no holes again. Do we have any vertical asymptotes? It looks like there are 2 vertical asymptotes in this graph at x equals 4 and x equals -3. So if I were to graph those vertical asymptotes, what did we say? X equals -3 and x equals 4. All right, let's look at horizontal asymptotes. If you're comparing your degree of your top versus your degree of your bottom, it looks like there is a degree of 2 in your numerator, a degree of 2 in your denominator. So it looks like on this one, P is actually equal to Q. Do you remember what that means about end behavior? As your graph goes all the way out to negative infinity, as x approaches negative infinity or positive infinity, what does that mean about horizontal asymptotes? It looks like here that you have a horizontal asymptote at the coefficients divided. So in this case, there will be a horizontal asymptote at y equals 3. Let's go ahead and graph that one. All right, those will be helpful in helping us graph or sketch a graph of this function. The next thing we're going to look at that's going to be helpful in sketching the graph are the x-intercepts and the y-intercepts. Remember from our last example, we can find our x-intercepts by setting by plugging in 0 for y, right? So the graph crosses the x-axis when y equals 0. So if I take that numerator of my fraction, set it equal to 0, I'm actually going to use the factored version because I would have to factor it anyway in order to solve. I'm going to use the 0 product property to set each of these equal to 0, and I get x-intercepts at x equals -2 and x equals +1. All right, if I'm graphing, what did we say? X equals -2, whoop, and x equals +1. All right, let's look at y-intercepts. Remember, y-intercepts can be found when x equals 0. So let's take our function. Let's plug in 0 for x. I use the factored version again to plug in 0 for x. You could use the original form of this function. You would still get the same final answer. You should get a -6 on the top and a -12 on the bottom, right? Which reduces down to y equals 1/2. So there's a y-intercept at y equals 1/2. This actually gives me a pretty good idea of what this is going to look like. I know I have to touch all 3 of these values, but be aware not to touch my vertical asymptotes on either side. So it looks like the middle piece kind of looks like that. Again, we now have to figure out what's going on the outskirts. What's happening to the right of that vertical asymptote at 4? What's happening to the left of the vertical asymptote at -3? So it's always helpful to kind of plug in values. I would plug in x equals 5 and see if my values are positive or negative. And how positive are they? Are they going to be way up here or are they going to be down here, right? Do the same thing on the left side by picking a value just to the left of -3. And it looks like I picked x equals -4. So pause the video for a second, plug in 5 and see what you get. Plug in -4 for x and see what you get so you can try to sketch the rest of this graph. When I plugged in 5, again, I used the factored version and I ended up getting a positive value. Positive over the value of 3, right? And so I'm not looking for an exact. You could do exact. That'll give you an even better picture. But I know that it's going to be a positive value much higher than 3. So I know my function is going to be up in this kind of top right corner. Do the same thing with -4. Plug in -4 for your x, and you should end up getting a value that is less than 3. And so I can graph it. I know it's going to be kind of in this region, being careful not to touch the horizontal or vertical asymptotes. All right, hopefully you have a good hang of it. We got a couple more examples that might be a little bit different, but make sure you're practicing finding all of these key characteristics so you can sketch the graph of any rational function.